Hello, today we're going to finish the rest of our chapter on acids and bases. We're going to begin with 7.6, and I have to tell you that if you hear some interesting back noise, it is because I'm outside. So if you hear cars or birds or chatting, it could be someone walking by. I got kicked out of my house because it's too noisy in there. So there you go. Okay, acid rain 7.6, here we go. So first off, pure water has a pH of 7, and this is because the hydrogen ions have a concentration of 1 times 10 to the negative 7th molarity, and the hydroxide ions in water have a concentration of 1 times 10 to the negative 7th molarity. And so because of that, you've got equal numbers of hydrogen ions and equal numbers of hydroxide ions, so you have got a pH of 7, a neutral pH. And this is just pure water, so anything else, any minerals, anything else has been taken out. Okay, so then pure rain has a pH of 5.6. And the reason why this is lower is because of the carbon dioxide that is dissolved in the water, and that forms a weak acid, which is called carbonic acid, which you see below. So the CO2, remember, we get that from a lot of different sources, but one of our main sources is because we breathe it out. So there's carbon dioxide, the addition of water. Notice how this is an acetic anhydride because you have a non-metal, which is the carbon, and then you've got the oxide. You're adding it with water, so remember how we smush this one together. You've got the 2 hydrogens, the 1 carbon, and the 3 oxygens. And this is carbonic acid. This is also carbonation. So this is what they put in your fizzy drinks to make them have that fizz and that burn. Okay. So let's talk more about acid rain. So acid rain, in order for it to be considered acid rain, it has to have a pH below 5.6. So we're talking about 5.5 or lower here. Okay? 5.5 or lower. Okay, remember, just pure rain, okay, we're dealing with 5.6, so that's slightly acidic, but acid rain has to be below that 5.6 mark. And acid rain comes from other pollutants in the air. So here are our main contributors. Sulfur oxides and nitrogen oxides are our main contributors of acid rain. So sulfur dioxide, this comes from burning coal in power plants. So when we burn coal, a whole bunch of sulfur comes off. And there's also metal smelters, and that mixes with the water in our atmosphere, and that can create acid rain. Nitrogen dioxide and nitric oxide, or another way to word this is nitrogen monoxide. Okay, these right here come from automobile exhaust fumes. So whenever we're driving anything, cars, buses, whatever, we're letting off nitrogen oxides that again can mix with the water, and that's going to create nitric acid. Some other things as well. Volcanic eruptions. When volcanoes erupt, it gives off a lot of sulfur, these sulfur oxides, and again, that's going to create sulfuric acid. So the air when a volcano erupts is very, very toxic because of the sulfur. And then it mixes with that water in the atmosphere and creates sulfuric acid. So it's just very harmful. Another thing is that lightning will give off nitrogen oxide, and that's going to create nitric acid right here. And if you remember, these are 2 out of the 3 strong acids that I'm going to have you memorize. So we're having sulfuric acid and nitric acids are being made from these nitrogen and sulfur oxides in the air. And that's what's going to create acid rain. Okay, so here's your pH scale. It's kind of a picture of what's happening here. Remember, at 7, we have our pure water, our neutral water. Ocean water is not as acidic. It's around an 8, and that is because of the salt that is in the water. And then we have normal rain at a 5.6, as you've noticed. And then remember, acid rain is going to be 5.5 or lower for your acid rain. And notice battery acid, which comes from sulfuric acid, is really low at a pH of 1. And then we've got, on the opposite end, we've got liquid drain cleaner. So this is very basic right here. Liquid drain cleaner is a very basic solution that can do harm as well. Now the effects of acid rain, and you can look these up if you want to, but it can deteriorate stone, specifically limestone. So if you ever go to a cemetery and you're walking around and you can't really see the definition on maybe a statue or a headstone, it's probably because it's been eroded from acid rain. Different parts of the country have more issues with acid rain than others. Also, deforestation. If you ever noticed that sometimes you might have a big area of forest that's dying, that could be also due to acid rain. Or bodies of water. They can also be affected by acid rain. It can turn the water color. It obviously can change the pH. If the pH drops too low, then your fishes and your plant life cannot survive, and so it's a big problem. And they can combat that with a base. A really common base they use is calcium carbonate, which is also used in making chalk. And they can put that in a body of water, and that will help neutralize that acid. Okay, let's continue on. Let's now go to section 7.7. We're going to talk about antacids. And if you think about the word anti, which means not, right? We're dealing with things that are not acids. So antacids, not acids, anti. Okay. The first term is hyperacidity. Hyperacidity is when you have too much acid, and this can be caused by overindulgence or emotional stress. So overindulgence is talking about maybe you're eating too much of a good thing. Like maybe you're eating too much cheese or fatty meats or cheesecake or chocolate, and that's going to create more acid in your stomach because your stomach's going to try to digest that food. Emotional stress can also make more acid in your stomach. And so these are all things that can kind of trigger that. Okay, the following bases can be used, and these are your antacids, okay, are these bases, and they can be used to neutralize the acid in your stomach. So this one right here is calcium carbonate. This is the one I told you about that is used also in bodies of water to help combat acid. If you have too much of this, you can become constipated. These are kind of some fun little facts I'm going to throw in here. Magnesium carbonate is the next one. If you use too much of this, it can actually do the opposite, and it can create a laxative. Aluminum hydroxide can also cause constipation if you have too much of it. And this right here is called sodium bicarbonate. This is another name for this is baking soda. And baking soda can cause alkalosis, which just means that you have too much alkaline, which means you have too much base in your system. Okay, when any of these bases are mixed with HCl in your stomach, it neutralizes the hydrogen ions. And so that's why people use things like Pepcid or milk of magnesia or Tums. The main ingredient in Tums is calcium carbonate, and that helps neutralize the acid in your stomach. Okay, and then the term alkalosis means that your blood is alkaline, and alkaline means that it's just basic. Okay, your blood is too basic, and this is actually a condition that can occur, and it's not good for your body, your blood to be too high or too low on the pH scale. It's very, very specific. And this is caused from overuse of sodium bicarbonate, which is your baking soda. So those are just some things. So on this page, just know there are antacids that are used, and these are bases that are used to help neutralize the acid in your stomach. Okay, the next part is just some acids and bases in the industry. So I would just maybe know what these are and some common uses for them. So the first acid we're going to talk about is sulfuric. This is the most produced chemical. Over 40 billion kilograms are produced per year, and this is used in battery acid. It's used in fertilizers. It's used in industry. It's also used in making many substances. Another acid is HCl, which is hydrochloric. This is a stomach acid. And the reason why it doesn't hurt our stomach is because our stomach has a mucous membrane lining, and that mucous membrane lining is thick enough that the acid doesn't hurt that lining. But hydrochloric acid can remove rust from metal. It can remove the mortar from bricks, and it can also remove those lime deposits that build up on like your toilet bowls or your faucets in your house. So hydrochloric acid is used a lot. My husband uses it a lot where he works. They make butter where he works, and they have to scrub down all their equipment with hydrochloric acid along with the floor after every day. Okay, now we're going to get into some bases here. So remember, this is the one base that doesn't follow the rules we've talked about, and you need to make sure you know that for the test. Ammonia is NH3, and this is used huge in fertilizer and also in Windex, which of course is just a brand of window cleaner. So it's used in window cleaner. It has a very specific smell. Another base is lime. The name of this is calcium oxide, and this is used in your cement and in your mortar. This is the most widely used commercial base. It's also the cheapest base. Another base is lye, which is sodium hydroxide. Sodium hydroxide is a very strong base. This is used in oven cleaners, and it's used in Drano, which helps you unclog the pipes in your house, like your sink pipes. It's also used in making soap, and that's kind of interesting. Okay, so that is it for the common acids and bases that are used, and this is the end of our chapter. If you have any questions, please reach out, and we'll plan on having the test on Thursday, which is May 7th. Okay, good luck. Bye.